Okay. All right. Fantastic. Um, I'm really glad that you guys are here, and it's a pleasure for me to speak at the group virtually. And if you're tuning into this session, then it might mean that you want to get more done. You want to move fast, and you want to run your systems with confidence, so you can deliver for your team, for your company, and for your customers. And this is the title of this talk is Azure DevOps for .NET Fall into the Pit of Success. And what that really means is that there's some rules where if you abide by these rules and kind of rules of thumb, these patterns, all of the products in the DevOps ecosystem tend to work well for you. And if you don't adhere to these rules, then a lot of the products just don't work very well, and you end up fighting it. So I know from experience that if you map out your software delivery process and then automate it, that you'll deliver more, and you'll absolutely love the results that you get. But we have an enormous problem, a serious problem, a problem we're going to have to solve. Most teams automate work for their own customers by producing the software. Then they saddle themselves with new administrative work to build and deploy and monitor the software that relieve their customers of their administrative work. So there's no reason that the cobbler's kids shouldn't have shoes, to use that analogy. I work with teams all the time where one of their most senior and most capable developers is a lot of times trapped in the task of deploying the software because they're the one who understands the software the best, they've been around the longest, and so they take their most experienced talent with the most knowledge of the software and then put them in that world of administrative tasks, just repetitive work, deploying the software. A deployment is essentially a set of administrative tasks. You're copying files, changing a config file, configuring a credential, starting a service, and you're doing it again and again and again, over and over again. Now, we all got into software because we saw the tremendous power that was available. We can write code and make the computer do something that makes ours and others' lives better. And so then we shouldn't settle for a process that takes us who are exercising technical creativity and then just do the same task over and over again. The computer can do those things. Now, if there's any managers that are here today, I want to share with you what might go on in the brain of people who have to do these manual processes over and over. Now, we as humans are always on the pursuit of happiness. And whether we get fulfillment in serving others or making something new, your people aren't finding happiness in the process of manual builds, environment configuration, and deployment. They want to get it done as fast as possible so that they can get back to why they got into software in the first place, to create things, to solve interesting problems, to make others' lives easier through the software. And as a result, of this dynamic, the manual tasks, they're going to be error prone, and mistakes are going to happen. And the more your staff endures the tasks that don't bring them happiness and satisfaction, the more they may consider leaving. And so whether you're an individual developer, whether you lead a team, or whether you're a manager in technology, this task, this talk, hopefully is for you. Now, we're going to go through the DevOps challenge. We're going to go through the structure of the pipeline, and then how to get started. And there are 7 key stages of the pipeline structure that we'll go through. All right. David, I'm going to leave it to you to manage the waiting room to allow participants in. I see a notification there. All right. Now, I want to, just for coming to this user group, I want to give you something, hopefully of value to help you get automated. A lot of the times we have lost weekends when a deployment goes poorly. or surprise overtime if a build goes bad or a deployment goes bad. And over my career, I've helped over 100,000 professionals across over 40 countries be better at software. And I have another book that came out late last year, .NET DevOps for Azure, and it really exposes the secret about how any team can have a fully automated DevOps pipeline using Microsoft platform by following a concrete 7-stage design. And the book goes deep into Azure DevOps services, Azure pipelines. This year, the GitHub Actions is really come on strong. But regardless of the tooling, it's the principles, it's the architecture that you really need to focus on. So here's what you need to do. Read the book. And by the way, just for being here, I'll give you a free electronic copy. Absolutely free. Just send me an email. That's probably the easiest way. My email's there on the screen. If you want to hit Shift Windows S and take a screenshot of that or write it down, take down my email, send me an email, I'll send you a free electronic book, and then read the book and understand what those 7 stages are. I'm going to cover them briefly here in this short talk, but the book goes into a lot more detail. And then launch your own .NET DevOps pipeline. The book has a complete public project that you can use as a model, and you can go through it in detail. And then you'll have a fully automated DevOps pipeline that uses Azure, that'll enable you to move fast and with higher quality as well. So I encourage you to do that. There's a lot of topics. I do almost weekly webinars, and you can go to clearmeasure.com/webinars to see a bunch of recordings of past webinars on a variety of topics. Another resource you might be interested in is the podcast that I host, and it's called the Azure DevOps Podcast. It's for people shipping software using the Microsoft platform. All right, so let's dive in. The 7 key elements of DevOps are the ones on the screen: pre-code design process, your version control structure, builds, full system testing, user experience testing, production releases, and telemetry observation, which is knowing what your software is doing. And I'm gonna touch on some of the key things in each of those that you need to think about. But before we get in, I wanna go over the image that you should have about DevOps in your mind. The DevOps pipeline can be thought of as a water pipeline, and that's the best analogy for thinking of a pipeline. And so, what do you want? Well, there's 2 things primarily that you want from a pipeline. You want a smooth and reliable flow. You want a smooth, reliable water pressure. Okay. Second, you want clean water. You don't want dirty water coming in when you turn in your sink. And so there's 2 things to measure: the water pressure in gallons per minute, and the water quality, which is how clean it is. A DevOps pipeline is the same. You want consistent water pressure, you want a smooth flow, and it doesn't make any sense for a water pipe to have just drips coming out and no water coming out. Same thing with software. You don't want to have periods where nothing is being deployed, nothing is being delivered. It's no good. You also don't want your pipeline a tidal wave of water, and you don't want the water pressure going from a little bit to spraying out like a fire hose. Same thing with software. You want a consistent flow moving through your DevOps pipeline. And if you're coming from a sprint process, then you're coming from a go hard, stop, go hard, stop, go hard, stop. And actually, mature sprint teams have actually fallen into a de facto Kanban process where the sprint boundaries have become a formality, and they kind of end up having a daily cadence of continually delivering software. Now, on the quality side, you want to filter out impurities. You want every step of the way to have a filter so that you catch the problems or you catch the dirt in your pipeline. You can't just leave a whole bunch of filters at the very end and have dirty water all the way until the very end. That doesn't work. You need to have water treatments and filters every single step of the way, and so with your DevOps pipeline, every single step you do needs to be coupled with a quality control, and that is a filter. So just keep that mental image in your mind. Now, what you're seeing on the screen now is a highly shrunken technical blueprint for the structure and flow of a pipeline implemented with Azure DevOps services, Octopus Deploy, Redgate SQL change automation. It has a 3-tiered deployment pipeline. By the way, you'll never have fewer than 3 environments, I'll tell you in a minute. But I want each of you to have this poster. Now, this is only the top third of the poster. You can print it out at your local print shop. This is the overall architecture. If you model your DevOps environments after this general architecture, you're gonna do well. This is the entire poster, and so send me an email as well, and I'll make sure that you get the high-res PDF version of this DevOps architecture poster. All right, now let's start going through these 7 areas. Now we're going to talk about the pre-code design process. For the overall flow, you see these 12 general steps. Remember I said that there was a minimum of 3 environments. And with a minimum of 3 environments, you need 1 of each. And everybody knows production. If you have a sales demo environment, well, guess what? That's another production environment, because if it goes down, that's a business disruption. If you install an instance of your software for each individual customer, well, now you have multiple production environments, but you need at least 1. Let's back up and let's look at the manual test environments. The most common is UAT, user acceptance testing. You need at least 1 manual testing environment. Many teams have multiple of those. Common names of those are dev, test, UAT, staging, sit, all kinds of names for manual test environments. But you need at least 1. Then the environment type that is missing in a lot of DevOps environments is the TDD environment. This is the test automation environment. And this is the first deployed environment that allows the implementation of continuous integration. There is a big problem out there, a big problem of misunderstanding, where people think that they have implemented continuous integration, but they don't have automated deployments yet. You cannot have continuous integration without an automated deployment. I'll tell you why. By the way, you can go back to the 2007 book from Addison Wesley with the title of continuous integration, and it really defines all the different stages of continuous integration. So the goal of continuous integration is to make sure that we can integrate changes from multiple developers quickly and continuously without destabilizing the code base that we have in our application. So the main question we're seeking to answer is, given the changes that we just made, did I just destabilize the code base? And in order to answer that question, we need to have implemented the 2 types of builds that continuous integration calls for. The first is the private build. The second is the integration build. And then we need to have the startup tests. So the private build is often missing a lot because, but the private build is a build script or build routine that each individual developer does locally that we'll go into in a minute. The integration build runs on a shared server. That's actually the most common because the tooling makes it triggered. But of course, if you're only doing a compilation, that's not really a build. That's just a triggered compile. And so we need several layers of test automation, static code analysis at a minimum to really have an integration build. And so integration builds are pretty action-packed, setting up environments, creating database schemas. If you only have a compilation, meaning if you're only calling msbuild.exe or .NET.exe, if that's all you're calling, then you have a good start, but there's a lot that needs to be put in there. But in order to answer the question, do I have a stable software system, or is what was just changed, did it completely break the system? We need to deploy it on a representative environment and start it up. And if we haven't done that, then we don't know if we've stabilized it. We might know that the unit tests run. We might know that the integration tests run. We might know that it compiles. We might know that Control F5 works on my box. But we don't know if we have kept the code base stable. So that's why we need that first line TDD environment, that test automation environment, so that we can complete the continuous integration process of making a build, deploying that build, and starting it up and make sure that the application starts. So that's really important. Now, I want to talk about the pre-code design process. That's these 4 elements at the top. And the first one is conceptual definition, the general requirements where we figure out what the heck we're doing. Then user experience. That's where we figure out how a person is going to use this new functionality. Technical design is validating or augmenting the architecture, choosing build versus buy decisions if we need a new library, if we're going to build something from scratch, validating design patterns if we need to bring a new one in, augmenting the database schema if that needs to be done, all those in technical design. Then the 4th design decision is, what does it mean to be done? What are the test scenarios that need to be run through in order to validate what we're about to build? And these can be manual test scenarios where it's just a bullet list of log in, navigate to this screen, type in some stuff, hit a button, validate, whatever it is. But simple bullets, it really puts a vice around the scope of the individual item, user story, card, whatever you happen to call your feature unit. So the developers know exactly what they're doing and exactly what's going to be done. These are 4 independent design decisions that are really going to turbocharge your DevOps pipeline. If your work tracking process doesn't call out these 4 types of design decisions before a developer puts their hands on the keyboard, then your process is going to move slow. We don't want it to move slow. The developers are going to start to try to write the code, but then the computer, which requires specificity, is going to demand that the developer understand what the goal is, the concept, how a person is going to experience this, what any technical decisions or patterns that need to be implemented, and what scenarios need to be supported, the acceptance criteria, the test design. And any of those design decisions that are omitted, the developer is just going to have to make an assumption. And depending on who's doing it, you may have different team members that just make different assumptions. And so in order to move fast, in order to keep your developers moving fast, you need to have those 4 types of design decisions made before you have someone trying to type out code, right? And by putting in, and so if you're tracking in a Kanban style board, then it's going to generally look like this. This is the minimum board configuration for even simple projects in order to move fast leveraging DevOps automation. And you wouldn't think that DevOps automation would really need a certain type of work tracking, but this is a huge, huge enabler. And so we see the first 4 design decisions before the development column. Also, the technical design column is the column where you start to decompose work. Because in conceptual definition, it's just a business idea, it's a general thing. It could be too big to implement. And on the technical design column, whoever the engineering lead or architect of the team is typically working ahead of the team up front, and not only determining libraries and what design patterns and if the architecture needs to be augmented, but is also thinking about the units of implementation and the sequencing of that and breaking down those features into implementable chunks. Ideally, in order to move fast, you want an implementable chunk to not take any more than 1 man day in order to implement. And that allows, in the DevOps environment, that simplifies the work of estimation, and it simplifies it down to just counting. Instead of having an estimate where it could be 1 day, or it could be the equivalent of 2 weeks, we say, no. We're going to break this down until each implementation chunk, until we believe that it can be done within a day. And when we have that, now all we have to do is count up how many there are, and we kind of know how many development days we have. And then functional validation, we see a mirror in the process. So that's important, those concepts. You want to fall into the pit of success. And so by implementing these 4 different design decisions as different columns, you can make sure that you don't throw something into the development column and then have a developer sitting there thinking, what should I do? And then now half a day goes by and you don't have anything implemented. The development column is for implementing things that we understand, not for figuring things out. So by breaking out individual design columns that are designed to figure things out, you're gonna make your process go a lot faster. Now let's talk about version control structure. There's a few rules in an organization that if you follow these rules, your DevOps pipeline is going to just fall into place. All of the products have this one product assumption, and that is that there is one DevOps pipeline per repository. And if you break the rule, then you're just going to be constantly adapting all these products. They were tested to run against one Git repository. That's how they meant to operate. You could have a large software system, but you want to segment your individually built and versioned applications into a single Git repository. So if your software system is broken up into 8 different applications, then you want to put each application in its own Git repository, and you want to have an integration build that builds everything in that Git repository. You package up everything in that Git repository into its deployable components, and then you deploy whatever was packaged from that Git repository at the same time, at the same cadence. And so if you have things that deploy at different cadences, then architecturally those are different applications, and so they should be in different Git repositories. This doesn't matter if you're using microservices or macro services, or if you're using a ham sandwich architecture. Each Git repository should have exactly one application. In a Visual Studio sense, that means each Git repository has one Visual Studio solution, and all of the projects, even if the projects have multiple deployed processes, if you have a web application, 2 Windows services or Azure functions, and a database, you got multiple things going on in that Visual Studio solution, that's fine that they're independently deployed processes, but they should all be one thing, one application, same version number, and when you deploy it together. Sometimes you might have some stress where you say, oh, well, we only need to deploy the web application, or we only need to deploy a change in the Windows service. Once those pieces start to have a different deployment cadence, you might recognize that they are starting to become separate applications and may need to be segmented from a source control architecture perspective. Sometimes once you automate your deployments, you may find that maybe the backend service doesn't need to be deployed because maybe you only fixed a spelling mistake on the website, but because everything's automated, you just deploy it as a unit because it is a unit, and maybe version +1 doesn't really change the functionality from the Windows service or the database, but because architecturally it's one unit, you deploy it together and it's no sweat off your back because it's automated anyway, okay? All right, so those are the rules of your version control system. Now let's talk about builds. We have 2 types of builds, your private build and your integration build. Your integration build actually has an architectural dependency on the private build script just because of the nature of what things that you do. And so your private build is run it on demand locally on each developer workstation, and the integration build is triggered, but they have a lot of overlap. In both of them, you're going to clean your environment, you're going to set up your new environment, you're going to stamp a version number on it, and in your private build, the version number may just be 1.0.0.0. But then you're going to set up your environment. In most of our applications, that means creating a SQL Server database, creating your database, setting up environment variables, anything necessary to validate that version of the software. And so in order to run component level integration tests, well, guess what? We have to have a local database so that we can run those tests against. And we want to make sure that the scripts that create the tables, and the triggers, or the indexes, whatever is in your database schema, that stuff works. And so we want to run it as a part of our build process. And then we compile. And a build can be thought of as just a big test. And so if you've ever studied test-driven development, then you've heard the terms arrange, act, assert. That's synonymous for set up, execute, and tear down. set up, execute, verify. And so the act is transitioning from source control to executable DLLs. And then in the assert column, we run our unit tests, run our component level integration tests, and then in the integration build, we want to run static code analysis. And when you first start running it, you're going to have tons of errors. Once you fix all those errors, you might want to consider failing the build if you have any new static code analysis errors. Capers-Jones does a lot of research in our industry. If you're not familiar with his research, look him up, Capers-Jones. And he found through all the research that there's 3 quality control techniques that when put together are very reliable in causing a team to output very, very high quality software. And the 3 tactics are testing, static code analysis, and formal inspections. Now, testing, and when he talks about testing, he means like rigorous testing. And that even holds true, back in decades ago when automated testing had to be run, on individual workstations, and automated tests were more of test harnesses than automated test cases. But if you have a formal unit test suite and an integration test suite and a full system test suite, then you're implementing the spirit of the testing and the research. Static code analysis, every language has analyzers, from the Roslyn analyzers for C# to SQL has analyzers, JavaScript has analyzers, HTML has analyzers. Every type of code has a command line static code analyzer. Put them in your build process. They're going to find problems, and you want to find problems as early as possible. And then the formal inspection, we'll talk about a little bit later, is making sure that every change to the software is inspected in a formal way. And so we'll talk about that soon. Now, after the integration build runs, or at the end of the integration build, when you know it's going to pass, right before we have the integration build configuration and Azure pipelines actually finished, we want to do our packaging. We want to package deployable release candidates. So conceptually, we're going to have one release candidate per version number. So if we have application, Contoso application version 1.2.500, that's one release candidate. But the release candidate can be comprised of multiple NuGet packages. Each of the NuGet packages should be whatever is necessary to deploy a particular process. So ASP.NET UI, great, that's a web application. And if it's targeting our app service, then it needs to be a NuGet package, everything necessary to deploy an app service. If we have an offline job, maybe Azure function or an Azure web job, then we're going to package that up as a NuGet package. Our SQL Server database, it's going to be packaged up as a NuGet package because we need to be able to provision and deploy a database. Our full system acceptance test, an in-unit test suite, that needs to be packaged up because in order to run it in a downstream deployed environment, we need to deploy the proper version of the test suite as well. And so we package that, okay? Now this is what Azure Pipelines is generally going to look like in a minimum case. Now, if you've been through my book and you've seen the public project, you can see 100% of this configuration. And if you've done it, you probably copied it. That's fantastic. That's why we put it out there. But this is what it's going to look like. You need at least one of each environment, and they need to run in sequence. We're going to automatically trigger a deployment to the TD environment because a test automation environment, there's no humans allowed in that environment. We automatically deploy to it, and if you're using Azure, you're going to automatically provision it, then deploy it, and then run your test suite, and then tear it down, throw it away. So the test automation, the TDD environment, is a very short-lived environment. It is not meant to support any kind of manual testing. That's what the manual test environment is for, and that's the second stage. And whether you call it dev or UAT or test or anything, those are manual test environments. And if you need 4 of them, great. Put 4 in there in sequence or in parallel, your choice. I want to stress to you, dev is a manual test environment, okay? TDD environments are spun up, used, and thrown away. No humans are allowed there. And so it's really important. Also, if you use a dev environment with a database on it, and people connect to that database from their workstations with a shared connection string, then you're going to be hampered in an automated DevOps process. You need to equip yourself with a process that creates a local SQL Server database on every developer's workstation so that you get rid of that global dependency. I want to share with you what the configuration generally looks like, what the pattern is when you're deploying. And by the way, in Release Manager, I'm intentionally not using the YAML support because the YAML support for builds came out last May, but it's not fully implemented. It works generally well in the build stage, but when you're deploying, it's not implemented to a level of usability. For example, getting packages from Azure Artifacts. I mean, you literally have to know 3 magic GUIDs in order to get it right. So it's not debuggable at all. And so we recommend just sticking with the step templates for Release Manager, just for usability and knowing what's going on. So, but this is the general pattern. We want to tell application insights that we're starting the deployment so that if something goes bad, we have that marker in there. Then there's a pattern, and I'm going to move my mouse around. We're going to obtain the database package. We're going to start with the database, start with storage, and we get the release candidate package. Then we do some things to provision or configure the environment. Then we do a step to do our deployment. And in this case, there's a lot of open source database migration tools that you just run the command line. If you want to go high end, the best option you can get is Redgate SQL Change Automation. It has fantastic tooling built into Visual Studio, builds off the SQL Compare engine. It helps you generate scripts, and then it has so many other features. But if you're just getting started, you can use Roundhouse. From order of popularity, it's DBUp from Octopus Deploy, then Roundhouse, and then Alias QL. But that's the pattern. Get the package, configure the environment, execute your deploy. Then you go to the next deploy component, which could be a web application. Get the package, configure the environment, do the deploy. Okay. In this case, we need one more step for starting the website. And then when we think that the deployment is successful, we want to do a health check. I'm sure that every single one of you has been in a situation where you thought the deployment was done, and you told somebody, go check out the environment. They checked it out, it was totally broken because a config file or a connection string was messed up. Well, we want to do that in an automated fashion. Something as simple as calling a web endpoint and then letting the web application just reach out to its database just to make sure it's online and connected. Because if it's not connected, the web application is down for all intents and purposes. We would rather the deployment report failure, if that's the case, than succeed. So that's why we want, at the end of every deployment, to have a health check. In the TDD environment, we want to do our testing. So we download the package of our test suite. We do some environment configuration, which is poking in connection strings and whatnot. Then we execute our step, which is executing the tests. Okay, and then we can see we're deleting a resource group because we don't need the TDD environment anymore. Now, I talked about formal inspections. This is the flow of a feature branch. Before we code, we specify the test scenarios in that pre-config deploy process, or the pre-config design process. Then we change the code on an engineer workstation on a feature branch. We do our private build. Now we know it's time that we can push a commit. And so we do that. And then the integration build runs on the build server. And then we package up a new release candidate from the branch. From the branch, we deploy to the TDD environment, do our deployment, run our automated acceptance tests. Now we know that we haven't totally messed up our application. And so it's ready for a pull request. By the way, if we haven't done this, we don't know if we're ready for a pull request. What if we broke everything? So we know we have confidence because it's been deployed and it's started up and it's run the existing full system test suites that we have. And so then we can create a pull request. Then our team evaluates the pull request using a standard team checklist that the whole team has agreed upon, and they check every item on the checklist. And when they hit that approve button on the pull request, they are essentially staking their reputation on the fact that they have validated that it meets all of the team standards. That's what it means to have a formal inspection. You raise a pull request up from just a simple peer review of Oh, you used the right coding convention, to an actual inspection. Every time the team does a retrospective, you want to ask yourself the question, is our pull request checklist still sufficient to maintain quality, or is it letting problems through? Every time a problem comes through, we say, wait a minute, how did this problem slip through? I thought that we had a pull request process, and where did it slip through? You want to augment something. Maybe you need a new item on your inspection checklist. Maybe you need a new type of full system test. Maybe you need a new class of unit test. Either way, you want to harden all of your levels of filtering. Now, when we deploy, we want to build and create the release candidate exactly once. And no matter how many environments we deploy to, we want to deploy that same set of release candidate packages. There is no concept in DevOps to building to production or build to UAT. Once we have a packaged release candidate, we never go back to source. If we find a bug in a downstream environment, that release candidate is dead. It will never see the light of day. It will never make it to production. It's dead. In order to fix it, we go back to source, we make a code change, and then we go through the process again. We have a new release candidate and new version number. And by the way, I did say we deploy to the TDD environment from branches. Then we do a pull request. Well, when the pull request is merged, that's going to generate a new commit, which is going to create a new integration build, which is going to create a releasable release candidate from the master branch, is going to deploy to TDD again, run the full system test again with all the changes merged together, and then after that, it's available to go on the UAT. I'll leave it to you, to have manual security approval buttons to deploy to every environment. That's easy to configure. But we want it automatically deploying to the TDD environment from every branch. It's a waste of time to create a pull request if you don't even know if the application will still deploy and start up properly. Now, when you're running your full system tests, you want to make a lot of screenshots. Azure pipelines and every build tool that can run tests makes it really easy to capture artifacts, capture attachments. So in unit, and if you use Selenium in the web application sense, you're just going to capture a screenshot, and it's going to take everything inside the browser window and do a screenshot with a JPEG or a PNG, and then you attach it. So this is what it looks like to attach the screenshots. If I zoom in a little bit, we can see a little web form, and you can't see the web browser. It doesn't capture the whole screen, it captures what's inside the web browser. So we see some navigation, we see some text boxes, a button, and Selenium is typing in text boxes, hitting a button, and so every step of the way, every step that it does, it takes a screenshot. When a test fails, you'll be so happy you have these, because you'll be able to see what the screen looked like on the step where the test failed. That is invaluable. Storage is cheap. Put this in place from day one for your full system test suite. Now, I talked about 3 different types of environments. You never want to do anything in production for the first time. Everything that you do in production from an automated standpoint, you want to have been practiced and executed exactly the same multiple times in environments prior. And so we do a lot more in the TDD environment than we do in the UAT, and especially than we do in production, but we practice like we play. And so once we get to a production deployment, even if we're splitting a database column or doing something that seems to be, or have a lot of changes, every individual change is kind of small and they're just sequenced in, and we might ask our question, wow, we're doing a lot of changes, is this going to work? Well, of course it's going to work. We practiced so many times on all of the environments ahead of time. Of course it's going to work. We've squeezed out the possibility for it not working. So I do want to stress that there's one thing that people still debate about database changes and the strategy of whether you want to use a state-based model or a migration-based model. A state-based model leaves the possibility of failure when you go to production, because in a state-based method, the tooling is going to take what the schema of you're deploying and is going to compare on the fly to your production environment, and right then and there generate the scripts that it thinks is going to make it there. Well, if you have removed a column, or if you have split a column, well, that column no longer exists in production. are we really going to let it just delete a column and expect to know how to migrate the data or split the data that was in that column? I mean, think about taking the phone number and splitting out the area code. I mean, you need a little bit of code to massage that data and split it out into its two columns. There's no tool that is going to cover and guess all the scenarios. Now, the easy scenarios, of course the easy scenarios work because they're easy, but we don't want a 90% solution. We need a rock solid solution, because when this thing fails, stakes are high, so you can't have it fail. And so that's why the migration-based approach has largely replaced the state-based approach, because its reliability is near perfect, because there's no room for variability. You have run the exact same scripts in every environment leading up to production, and you're going to run those exact scripts against production as well. All right, let's talk about telemetry. You want every individual process of your application emitting telemetry to someplace that's off the server, that's out of the environment, so that your people can access it and query it. You don't want to have to give your staff production level environment access just to access the logs and to figure out what the thing is doing. So that's where application insights comes in. You want to make sure that application insights is in a place, whether in a different resource group or a different subscription, so that you don't have to give people more Azure privileges than you want to just to be able to query, hey, what do these applications do? Okay, you want to make sure that information from all of your running processes in the application go over to application insights. Now let's talk about the concept of telemetry a little bit. Everybody who's been doing software for any period of time knows about logging and knows about how to emit some logs. Well, we need to get those logs off the server, off the environment. We need to centralize those. Great. But logs are not sufficient for knowing what the software is doing at any given time, or being able to query and get information from that. This is where we need to raise up the concept of logs and get to true telemetry. So to get there, we need to add two more concepts: metrics and events. And probably a lot of you enable data warehouses or business intelligence capabilities for your users through your software. Well, if you're not familiar with data warehouse architecture, go look up the books on the Kimball method for data warehousing. There's a few building blocks, and the main building block data structure is the fact table. That's kind of the heart of a star schema, and the fact table has two types of data columns. One is a dimension, and the other is a fact. Dimensions are largely strings, sometimes they're dates, and then facts are numbers. So the key about the numbers is that they are suitable for aggregate functions: sum, min, max, average, and the dimension columns are suitable for grouping and filtering. So from a query perspective, you would say select sum of a fact column, min of a fact column, group by, and then maybe the month column if you want to have all those metrics by month. If you want to know the average number of transactions for a particular user type over the month over month, and have a data series to be able to put on a line graph. And so what you're doing is you are creating a new data store that enables you to attach all of the marketplace's business intelligence tools, Power BI, Tableau, even Excel, Power Pivot. You can attach all of those to a data source. And so you need metrics and events. How you do that is by instrumenting your application. Every screen, every button, every action that a user can do needs to be named. And now you have your events, okay? So you have your library of events. Everything's a unique name, a whole bunch of constants, right? You have event names for, hey, the user pulled up this screen, the user clicked this button. Those are events. And then you want to emit those events. You're just creating objects, and you send those events to application insights or whatever tool you're using. And there's plenty of tools, Stackify, New Relic, Splunk, and there's more coming out every day. I mean, Marketplace has lots of great tools for that, for offsite centralized telemetry stores that have good querying capabilities and good alerting. But you want to emit your events anytime the user does something, or when the application starts up, or when the application experiences an error, or when the application restarts, or anything that's happening. Okay? And every event needs to be coupled with as many metrics as are relevant. Definitely a timestamp of what's happening, counts of things, any metric, any number you can think of that's going. Now, just the existence of an event comes with an implicit number, and that is that it's there. So you can count the number of events. For example, it's great to be able to query that says, hey, over the last some period of time, month, show me the users that have a count of login event, a count of failed login event greater than 1. And you can narrow it down to literally have an alert that tells you when somebody is just at the login page and is fail, fail, fail. Or how about if someone has more than one reset password workflow in the same month, and you find, wow, we have a certain number of users that use our application intermittently, and every time they come back, they can never remember their password, and they're always going to reset password. Wow, this user's resetting their password every single week. And you can infer things about it, you can learn and be able to support your users better because you know what's happening. And you're equipping yourself with a store of data that is structured in a way that's easy to get information out of. You are creating a data warehouse from the normal usage of your application because you instrumented it for telemetry. That's important. In application insights, just by connecting it to your .NET application, you're going to get all kinds of stuff like application insights knows .NET, including what SQL queries are being run. So definitely do that if you're in Azure. And also the deployment markers for when you do an automated deployment. So if your numbers and alerts start going haywire, you can see, oh, this happened right after a deployment. If you click on that deployment marker, it'll give you a link directly back to Azure Pipelines and exactly what versions that you can kind of have traceability. All right, so these are the 7 key elements that you need to design in order to have a world-class DevOps pipeline. And I really don't want you to perhaps stay frustrated by a slow and manual process. Take pride in delivering to customers faster. You can automate your DevOps pipeline, and that'll enable you to ship software quicker and also preserve your weekends. So remember, send me an email so I can send you a free electronic copy of the book. If you'd like a high resolution version of that DevOps architecture poster that I showed you, and get the book and use it as a model to get automated. I also do weekly DevOps education webinars, and the next one tomorrow actually is on GitHub Actions and where that fits in with your DevOps architecture. And so also be sure to subscribe to my podcast, the Azure DevOps Podcast. And at this point, we can check and see if there's any questions or discussion. All right. David, I'm not sure if there's any questions that have come through on your end.
Not from the chat. I've been posting a couple things off and on. I put Jeff's email in the chat, Jeffrey at clear-measure.com for a free ebook if you'd like to do that, and also kind of plug in there to subscribe to the Azure DevOps podcast. If someone has a question, go ahead and unmute yourself and ask, or if you don't want to do that, go ahead and pop in the chat. Should be no problem there. While we're waiting on that, we'll just go ahead and wait a moment here. And anyone has anything, just do you plan on having some I was just to suggest some in-depth discussions on this, meaning the in-depth discussions on Azure DevOps. Is that what you mean?
Like to know about release pipelines. So yeah, this talk kind of touched on the architecture, the big decisions of every step, and so I wrote an entire book going really deep on every topic, and there's a complete working example project that's public on Azure Pipelines. You can dissect and go through. So yeah, get the book and get as much detail as you want, because there are a lot of things that you need to do to have a high throughput DevOps environment for your team, but there's so much to understand that so many people are confused, and so my goal is to be able to simplify the big decisions so that you can really fall into a pit of success instead of a pit of despair. And so the things that I just covered are the mindset that you have to be in and the big decisions to make as you implement the details of the tooling.
And so Jeffrey, in the ebook that you have there, I'm going to pretend I'm real dumb with this, but in the ebook, I would be able to get a deeper, in-depth discussion about pipelines and some of the other variations on that. Is that correct?
Absolutely. It even walks through, if you go through the entire book, it will walk you through configuring every feature, putting everything in place, and you will have a working DevOps pipeline for yourself in your environment.
So then now we have another question. Do you have any tests or benchmarking APIs in the pipeline?
And you might want to unmute to expand on that, but if you're talking about benchmarking performance in the Azure pipeline, I don't have any that I can show you here, but there are some servers popping up because Microsoft deprecated its web test and load testing capabilities. But BlazeMeter is a service that you can use for doing a spot check for performance numbers. And a lot of times, instead of doing like an hour-long, ultra-high scale performance run from external sources on BlazeMeter or LoadRunner or whatever cloud platform for scalability testing that you want, you can oftentimes do a 5-minute test or a 10-minute test and measure how many iterations that your environment was able to do. And then, because you're capturing that data, you can trend it on a line graph, and if you have a change that causes that line graph to start dipping, start going in a different direction, then that's an early signal that you just accidentally adversely affected the performance characteristics of your code base. And on your box, you might not even be able to tell. And on a test environment, you might not even be able to tell. But it's a signal that once you get to production with a lot of people using your application, you might have just totally broken the performance characteristics. And so if you live in that type of environment, that's a technique that you can use. So I hope that answers the question.
It sounds good to me. I'll read up the next question that I have here. So creating a local database for the developer is fine when you are starting from scratch. But what do you do when you have a legacy database? Should you still script out everything? That could take months. And I'm going to add something to this question. What about PII?
Yeah. Okay. So there's two architectural concepts. One is a legacy data. Let's take the one side of the spectrum where you have a really old application and it has a database. All right. I'm going to make the assumption that that database is architecturally owned by that application. Yes, whatever tables, views, whatever that schema is, we should script it all out and put it in the Git repository. And I mean, we may have to segment it out into different SQL scripts running different transactions just to be able, for it to be able to run. But we need to script it all out and use one of the database migration tools so that I can run it locally and create an empty version version of the actual database, because I need the entire schema of that database locally in order to run the application locally, because it depends on those tables existing. And if I'm going to write component level integration tests that go back and forth to that database, I need to be able to have the code actually insert records into the tables, read records from the tables. And in the private build script, I'll also want a routine that inserts just enough automated seed data into that database, because oftentimes applications don't work if the database is absolutely empty. You need at least some records in tables in order for it to do anything. Now, on the other end of the spectrum, there's a lot of legacy environments where we go around and we try to start doing this, and we architecturally discover that a particular database doesn't belong to any of the applications that have a connection string to it. If you go around every single one of the applications and say, well, does application A own the schema? Well, no. Does application B own the schema? No. You find that you have a dozen applications that have the connection string and use the database, but not a single one architecturally owns the database. They just access the database. And so we have to realize in those scenarios, and this happens a lot with these legacy systems that have been around a long time, is that architecturally, you have a standalone software system implemented 100% in SQL Server technology. And you have other applications that merely have a dependency on that system, and the integration transport that has been used to access the system is SQL, okay? Now, you might not like that's what you have, but it's good to recognize that that's what we have. So from a DevOps perspective, we set up a Git repository for that database by itself, a DevOps pipeline for that database by itself, a private build, integration build, test suites, a packaging step, deployments, and that database, architecturally, it is a standalone system. And so we start versioning it, we start deploying it, and it has a DevOps pipeline. But then there's other applications that depend on it, and they need to use it. So how the heck can we do that? Because they don't even have access to the schema. Well, it's just like, it's same thing with other dependency management. We take the schema, we package it up as a NuGet file, we push it to our Azure Artifacts, which is a private NuGet server, and now the other applications that need access to the schema go and grab that NuGet package and pull it in as a NuGet package, just like we pull in every other library as a NuGet package, and then we use our SQL migrations tool to access the schema scripts, and now we can create an environment with that schema, and it's essentially read-only because we got it from an external source, but now we can as one of the applications that needs access to it, run tests that round trip to that schema because we have the ability to create a copy of it in our environment. And then in our downstream deployed environments, we have, we obviously punch in the connection string, and now they can actually go against the real database. So you have to do some analysis to understand what your architecture actually is, and understand what your application boundaries are, and then you can determine what your application boundaries are, and every application should go in a Git repository, and what application dependencies you have, and that needs to be managed at deploy time. So I hope that helps.
All right, so are there any articles on how to implement application insights that can capture for both mobile and web APIs as a holistic view?
I do know that the mobile support, if you're talking about Xamarin, that has a little bit different tooling story right now. Microsoft Application Center, App Center, that is kind of a parallel universe because it was an acquired pattern, and the full Xamarin support has not been pulled into Azure pipelines. And so right now you're going to have a branching where you're going to build the application in Azure pipelines, but then you delegate, you connect over to App Center for the device testing and the deployment, and also the logging. And App Center also supports WPF and WinForms, and so the telemetry of that App Center has better support. But unfortunately, not that I'm aware of, there's not one cohesive that'll automatically do that for you.
So, is there any suggestion on a static code analyzer supported by DevOps for .NET C# projects that are easy to read and convey to the team?
Absolutely. The Roslyn ones are where you should start. It's built in. It's a command line switch for MS Build. Also for .NET Core, it's built in. You already have it. There's nothing to buy. Next step up from there is 2 commercial products. Both of them are really good. One is Independ, and the other is SonarQube. And both of them are live very well within an automated DevOps environment.
How can someone new to DevOps getting started to get a job for something like this?
Get really good at it. That's my...
Just like every other job, right?
Be a voracious learner. I mean, read every book, text, article, video you can get your hands on. DevOps, I will say that there are some IT system admin tasks within DevOps that entry level can apply. But DevOps as a practice, I believe it's more of an architectural level skill because it requires knowledge of such the full breadth of software engineering and software delivery that you really need that full understanding. You need that architectural view. So if you're just getting started, I'll be honest with you, it's going to be hard because you don't yet have the experience to have the full view. I mean, you may be able to learn to configure some of the products and make an automated build and an automated deployment and implement some of the products, and that could probably be a good target. But you need to study all kinds of practices and have a full understanding of what's out there and what's available. So yeah, you can do it. Get cracking. Just you got to be a voracious learner.
So what would you say is a summarization of some of the more common roadblocks that can prevent clients from getting to the finish lines that you've described here?
Just knowing what to do, having the right architecture, and what I discussed in this presentation was basically the rules of thumb to fall into the pit of success. If you violate any of these rules, you're going to be beating your head against the computer for weeks and weeks and weeks trying to make something work, and it's just not going to work. That's why I compiled all this stuff, because from helping so many teams all around the world, we have the same things that come up over and over again. And if you omit or if you violate one of the rules of thumb that I just covered, that's going to cause you to just your client to flounder. I mean, we have some teams that we've advised where they have a shared dev database, and that database is sufficiently large to scare them, and so that they don't believe it's possible to run it locally or do any kind of movement on that, and so they continue to have a shared database. And then somebody makes a change to the database, everybody else on the team is blocked because something changed, and then they wonder why they're moving so slow, but they won't actually fix the root of the problem because they have a fear of how large the database is. We have done this for insanely scary databases. It's so there. If you decide not to implement one of these rules of thumb, then it's not going to work for you. But if you implement all these rules of thumb that I just covered, it's going to fall into place for you. Now, depending on the architecture of your application, there'll be some sticky points if you have some complex parts of your application that are hard to move. But that's because those parts of your application are hard to move, not because you need to go searching for a different DevOps tactic.
So, coming from the open source world, you have the Elk stack for analyzing logs and other types of software like that. Can you go into some detail on how application insights could be used in a similar manner? Could
Sure.
you maybe provide some more details on that?
Yeah, and the next question, do you do consulting? The answer is yes. My company, Clear Measure, is a consulting company. We are available for hire. We're a software architecture company that works to make Microsoft platform development teams self-sufficient, so you can move fast, deliver quality, and run your systems with confidence. So by definition, we are available to hire. Just send me an email, and I'd be happy to have a conversation. On Elk versus App Insights, I don't really have a loyalty or affinity to any of these tools. That you need something from that class of tool. You need something that can accept telemetry and store it and organize it, and then allow you to query for it. Lots of people successfully using the Elk stack. We've used the Elk stack. It's great. Application Insights. Lots of people successfully using it. Same thing with Stackify, New Relic, Splunk. We're actually blessed to have so many good product suites in this category. All right, so it's not you got to pick one product or it's not going to work. Elk, if you've already got Elk, great. You are set up from a product perspective. Now you need to instrument your application so that you have all of the events married with metrics so that you can have the right structure of data to put into your Elk stack as an input. That's the key here, okay? Not use Elk or Application Insights. Pick one of them. I don't care. Any of them will work. That's the key.
So as an additional point to what Jeffrey just said there, Serilog is a fantastic NuGet package that you can use to integrate with all sorts of providers like Elk, Elasticsearch on AWS, or Splunk, or all sorts of things, and you can add a lot of different options on that, all with some very simple, very easy to use code. And so if anyone doesn't have some sort of logging framework like this, oh gosh, like spend a couple of hours and do a small test app, get yourself in the realm of like thinking in this direction, and then go hog wild on your tools, on all your processes, and implement this, because it's so valuable to have.
Yeah.
Well, all right, so last question we have here. Have you come across a pipeline implementation for Azure APIM and Azure Functions CI/CD? Any suggestions for this?
So yes, we have. I mean, pretty much any combination under the sun across all of the clients that we serve. And actually, just last week, I was involved in an architectural discussion with API management and the nuances of some of the intersection with network security groups in Azure, and also how to deploy and set not just the application that run the APIs, but also the networking infrastructure and the resources in which they live. So the answer is yes. Unfortunately, I'm not aware of a public or open source implementation that I could just point you to hey, go get this and drop it in place. And that is one of the difficulties, is that there's so many different resource combinations in Azure, between .NET Framework and .NET Core, and then GitHub Actions and Azure Pipelines and Octopus Deploy. There's so many combinations that as an industry, we don't have just this one library of templates where we say, oh, I'm using XYZ, let me go grab the template, let me drop it in, and I'm done. I hope that we get to that. For instance, the example in my book, I had to pick some architecture, so I picked web application and an Azure App Service, offline job with an Azure function, and then Azure SQL, because every application has that. And if you want to drop in ARM templates and automated deployment, well, you've got every script that you need, and every Azure Pipelines configuration just by going through the book and looking at the public project. But specifically for API management, No. So I guess for Azure Functions, you could pull that part from the book in the public sample, but for API management, we can do it for you. We can design it for you, but I don't know of a public just template that's out there to point you to. So I think that's the best I have for you there.
So Jeffrey, do you think that maybe Jenkins might have some pipeline implementations for that, or plugins possibly? I would think so, right?
Well, I mean, the products are going to say, oh, here's a way to deploy something to Azure, or maybe they have a library for Azure API management if they do go down to that level. But they're never complete. They're just enough so that the product can send something to Azure. Actually, if the product that has the most comprehensive library for all of these deployments is really Octopus Deploy. For deploying to Azure, and AWS, their library, I mean, is just phenomenal. And just in the last year, they've augmented it with all kinds of Kubernetes scenarios. And so if you want to be able to do a deployment and not have to understand the ins and outs of the different environment choices, you just want to pick which one, then Octopus Deploy is the king of the castle there. And it integrates really well with any build server, works really well with Azure Pipelines, Jenkins, TeamCity, whatever you're using. And so I could point you in that direction.
Looks like we have one last question so far. We see App Center functions duplicated in DevOps, but it is hard to set up what is in App Center in DevOps. Do you know Microsoft would ever merge these two, or do you believe they will keep them separate?
I think that they're probably going to keep them separate because organizationally they're separate teams, and software architecture tends to follow the shape of the human level organization. And so in order for them to be merged, they would have to do an organizational reorg and make the teams one team. And App Center focuses on native applications so much. The Xamarin applications, iOS, Android, WinForms, WPF, and as well as it being it was an acquired product. It wasn't built inside from Microsoft. And at the same time, Azure DevOps, they focus so much on Azure native server-side applications that there is a pretty big divide there. But when going from you can do all your builds, in Azure Pipelines, and then just switch over to App Center for the deployment, for pushing things to the App Store, for everything else that it provides for native applications. All right, well, hope that helps. I appreciate you having me. This is fun.
Jeff, thank you so much for joining us tonight. I really appreciate the talk. I really appreciate the subject matter here as well. And thank you so much for letting us share some of your time tonight. One thing for everyone, it's very likely we will do this again next month. And I have learned a bit about how to do a Zoom meeting in this manner, so I will change a few things for next month. Thank you all for joining. Thank you, Jeff, for spending time with us. And again, Jeff is with Clear Measure. He's down in Austin. I'm sure that if you had some consulting work that needed to be done, Jeff's a great guy. He's been doing it a long time. They're great people down there.
Be the gray hair.
Thank you so much, Jeff. And I think there was someone that said that they were recording the meeting, so I will get with them afterwards. And if everything turned out great on the meeting, I will post it on the website. I will tweet about it on my Twitter and on the NDD NUG Twitter as well. Again, from the North Dallas Developers Group, thank you very much. Have a great evening.
All right. Bye, everyone.
Bye, Jeff.